Hey guys, welcome back to Guys Teach Stuff. So today you'll be learning about chromatography and distillation from topic 7Ed and 7Ee in your Exploring Science textbook 7 with myself, Sean, the best teacher on this YouTube channel. So first, let's take a look at chromatography. Now, if you haven't noticed already, all of 7E is about separating mixtures, and chromatography is the same. So, if you haven't watched my first two videos, I would highly recommend clicking the pop-out banner in the top right to see the in-depth videos, or click the link in the description. Anyways, after water has been cleaned, it must be tested before it can be used as drinking water. Tests for many different substances are carried out to make sure the water is safe, and that's where chromatography comes in, because it is one of the techniques we can use in water analysis. Chromatography separates substances dissolved in a mixture. That's it. And that's why we use it to easily identify and analyze each substance the mixture contains. It's important to understand that there are many different kinds of chromatography. Paper chromatography is the simplest method, and the one you will most likely use at school. It can be used to find out which colors are mixed together in different paints, dyes, and inks. So how does it actually work? Well, a concentrated dot of the mixture you're examining should be placed near the bottom of the special chromatography paper. The bottom of the paper should be dipped into a solvent, and the solvent carries the colored substance in the paint, ink, or dye up the paper to form a pattern called a chromatogram. The main thing you need to remember and understand is that chromatography is when different substances in a mixture are carried by a gas or liquid solvent up the paper and separate doing so. This is because the colors are carried at different rates because they are not equally soluble. A color that is the most soluble will travel the greatest distance, and therefore colors that are less soluble will move a shorter distance. Now, here's a diagram and a real-life example of chromatography from your textbook. As you can see, the inks have separated after being dipped in the solvent. The last thing I need to point out is that in paper chromatography, the starting line must be drawn with pencil. This is because the pencil lead does not dissolve in the solvent, thus it will not affect the separation. Now, the one you've all been waiting for. Drum roll, please. Distillation, 7Ee. Now, I know I briefly touched on this topic already in the first video, link in the description, but this will be way more in depth. So let's get started. So what we're going to go over today is simple distillation. And like last time, we are heating a solution to get pure water by evaporating it to leave the unwanted dissolved solids behind. As you can see, we have a heat source, most likely a Bunsen burner, that is evaporating the water in the flask. And the new thing are the anti-bumping granules. These basically prevent explosive and dangerous boiling as they provide a large surface area for the bubbles to form on. So after a while of heating, the water will reach 100 degrees Celsius, which is actually the boiling temperature of water. You'll be able to measure that with the thermometer at the top of the flask. And basically, this will rise because hot air is less dense than cold air, and then it will enter the condenser. What I did not fully explain last time is how we can actually condense the steam/water vapor to obtain the pure distilled water. So basically, we have this condenser, right? And there's cold water flowing in and out. And so the steam or water vapor, by the way, they're the same thing, gets cooled down as it enters the condenser and actually condenses back to a liquid, back to water. So this actually cools down the vapor and changes its state, condensing it back into a liquid, and of course, dripping out the bottom, we have pure distilled water. By the way, if you didn't know, this is simple distillation, not fractional, and it is used to separate a solvent from a solution. It's also useful for producing water from salt solutions, which I'll go on to later. It works so well because the dissolved solute has a much higher boiling point than the solvent. So basically, the solvent will always evaporate first. Then it can be cool and condensed as I showed, and then we have the pure distilled water. And we have to remember, linking to last week, that the remaining solution in the flask becomes more concentrated in solutes as the amount of solvent in it decreases. The last thing I need to go over today is examples of distillation in real life. So this won't take too long, 2 minutes max. This is actually really useful, and I found this quite fascinating because I didn't know how much we actually use it in real life. So let's get started. So first we have the basin solar still. The dirty water is the solution and sunlight is the heat source. So of course we want to get rid of the dissolved substances in the dirty water, and the sunlight will evaporate the water. This water vapor will probably condense and be captured on the transparent cover, move down there and get collected in the chamber on the right. So this is a very useful method. It's very cheap in providing clean water, especially for poorer areas of the world in remote places. It's so good because it doesn't produce greenhouse gases and it does not use a lot of energy. So as many of you may know, dirty water and seawater are not safe to drink because they contain too many solutes. However, drinking water can be made from seawater using a process called desalination. This basically removes most of the salts from the water. However, it's very expensive and is only suitable in some places of the world. Of course, desalination doesn't only involve distillation. There are multiple processes, but distillation is one of the processes they use in these desalination plants. Now that I have explained everything, let's look at this checklist. You should now be able to describe how chromatography can be used to identify substances in a mixture, explain how chromatography works, explain how distillation can be used to separate a solvent from a solution, and lastly, give examples of where distillation is used in real life. Thank you very much for watching Guys Teach Stuff. Please come back to this channel for more science videos that will be uploaded in the near future. Thank you, and that's it for me.